Professor Rosie here in the shop. I thought it might be fun today. A lot of people ask me, what are these tubes? What are these things you're always talking about and testing? Where did they come from and how do they work? So we're going to try to do the 5-minute professor today to give you the most basic background so you'll have an understanding of vacuum tubes and just how critical they were. You know, we've all heard of Thomas Edison, and back in the late 1870s and 1880s, Thomas Edison was struggling mightily to produce the electric light bulb. One of the big problems he had was when he would have something would burn as a nice filament and glow, it would often produce a soot or black carbon powder on the inside of his globe. Well, who wants a light bulb that's going to turn dirty after 5 hours or 5 days? No good. So Edison tried different ways to beat this soot that was developing on his light bulb, and out of frustration he decided to put a metal plate at the top of one of his globes and seal it in with his filament that would glow. And he hoped that if he put this in a little bit of circuit and made this positive up here, he knew this was negative down here, this filament that was glowing, it was shooting off electrons. He hoped that maybe this plate would collect that soot and keep it from depositing on the rest of the plate. Well, he wanted to see what was going on within his new circuit, so he put a small electric meter there to detect if anything was going on. And when he switched on the power, he fed in his battery there, and when he switched on the power, he noticed that the meter was showing that there was electricity moving through the circuit. He was like, what the hell? You know, there's not even a direct electrical connection between this glowing filament down here and the metal plate above. How can electricity flow when there's not even a wire connection between those 2 points? He had discovered what we call the Edison Effect, or a thermionic process. How do you like that for the $1 million word today? Where heat on a metal plate causes electrons to be released that flow through space, okay? And they were being collected up here, and the circuit was being completed continuously. The Edison effect was discovered, and it was Thomas Edison's only real discovery in his whole lifetime, but it was an enormous one. Remember, he didn't even have much of an education, but he was a keen observer of life. 99% perspiration and 1% inspiration. Well, he discovered something pretty cool, but being Thomas Edison, he continued on with his light bulb until he achieved success. But he did patent this, and it became known as the Edison Effect. Over in the UK, of course, everybody followed Thomas Edison. There was Professor Fleming over there at a college in London. And he was fascinated by this Edison effect, or this ability of electricity to move like a ghost through space, even though there's no visible means of connection. So he wanted to see if there might be any practical applications of that. So he started building some of Edison's bulbs here. And he put the metal plate on top, and he put a positive charge. He hooked it up to a battery, just like Edison did. And his filament would glow very bright. He put his meter in, and he was able to duplicate Edison's experiment. When he put the current to the circuit, he noticed that the electrons, like ghosts, they moved through there, and they were able to be seen by the electric meter, seeing them moving through. Didn't know what it was, didn't know how it worked, but he observed and verified what Edison had discovered some years before. But here's where it gets good. You know, Thomas Edison was all about DC power, right? Remember Tesla, AC, the battle of the currents, AC versus DC, and Tesla hated Edison, and Edison hated Tesla, and Edison tried to convince people that AC was deadly and you could never have AC power. DC power was the way to go. Almost killed Edison's career and almost killed him. But Fleming had no such stubbornness. So one day he decided to experiment. Instead of using a battery, he decided to feed alternating. Instead of direct current of a battery, he decided to feed alternating current. What we have in our household today, 120 volts, 60 cycle alternating currents. I'm not sure what size the alternating currency it was that he put in, but when he fed that into the circuit instead of direct current, what he noticed was instead of getting the full sine wave or the full output of positive, negative, that's all AC is, alternating currency. One fraction of a second is negative, the next fraction is positive. It's going up and down, above and below the zero line here. He noticed that when he fed alternating currents into Edison's bulb here, that what would happen was, because this was positively charged up here on the plate, when he fed the alternating current in, the positive part of the cycle would be repelled, because positive repels positive, and only the negative would carry through of the alternating current, or what was below the zero line. Fascinating. What he'd actually done unwittingly was he had discovered what's called the first rectifier, or the first device to take AC and convert it to DC. By repelling half of this wave coming through, he only allowed pulsating direct current to come through. Well, this had huge applications to radio, because radio, telephony, all those kind of things, they don't like AC within the sets. They don't like AC within their circuits. They like to use DC. They love DC. They love direct current. They hate that AC. It causes hum and other things in the circuits. So here was a way to practically put direct current into radio and telephony circuits and telephone circuits and things like that. It was a way to take AC and convert it to DC, because you're only taking half of the AC wave at any point in time and feeding it through for direct current. Pretty slick, okay? Well, it gets even slicker here, because a guy in the United States called Lee DeForest, working out of Chicago, sometimes with Western Electric, the precursor to Bell Laboratories, he was experimenting with Fleming's diode. We call it a diode because it has two parts. It has the filament that heats up and glows, and it has the plate that collects the electrons when they move across the vacuum. Well, he started experimenting with Fleming's diode here, and he figured there had to be a better way to control it and to make it more useful. So what he decided to do was something to try to develop something that would regulate the flow of electrons across this vacuum within, from this filament to this collector plate inside there. He experimented with different things to control that flow. And finally he developed what's called the grid, and we still use that in electron tubes today. It's a thin piece of metal mesh wire that sits between the filament that glows red hot and the plate above that collects the electrons as they move across. And he found out that when he put a small signal in that grid, like a radio signal, an antenna, a signal coming off an antenna, which itself is an alternating current, just like your voice is modulated up and down, it's an alternating current too. He found out when he put an alternating current onto that little control grid, onto that little piece of mesh, that the signal that came through from the plate side up here was tremendously amplified in size. It was perfectly reproduced and perfectly amplified many times over. A tiny little signal became a gigantic signal. Now when that signal came in, at times, of course, since it's alternating current, radio waves are alternating current, at times it would be positive and at times it would be negative, that signal coming in, right? Up and down the zero line. Well, every time it would go positive, less electrons would flow through to this side. Every time it would go negative, more electrons would flow through, pulse through to the other side. So it was like a gateway valve, and that's why the British call them valves, that would control the flow of electrons moving through. Well, when he put that signal through, that signal was tremendously amplified on the other side, and he had developed what was called the first triode, or the first practical amplifier within a vacuum tube, or something that takes a very small signal and turns it into a very, very large output. Well, you know what? Three geniuses, Edison, Fleming, and DeForest, 3 hardworking guys. But boy, the lawsuits flew fast and furious between Fleming and DeForest. He's each claimed really to be the father of the modern vacuum tube or valve, and of course, Thomas Edison with his Edison Effect was really the one that was the original discoverer of this whole process. Well, it all ended on lawsuits, and finally the United States Government Patent Office ruled in 1943 that DeForest would prevail and that his patents would hold up to, and I guess everybody was happy, but who knows, right? There are a lot of big egos that work on this board, I'll tell you. Well, you now know what a rectifier does and how it works. It changes AC to DC by cutting off half of the wave going through and turning it into direct current. You also know how an amplifier works by putting a small signal on the grid between the filament and between the plate there, and that is alternatively going positive and negative, and when that signal goes real positive in a big way, and depending on how much power comes into your filament there, it's tremendously amplified. You now know as much about vacuum tubes as I do, okay, and how they work. Of course, there's other varieties too besides the rectifiers and the amplifiers, the detectors, in other words. But you've now earned your diploma, and you understand what a vacuum tube is and how some of the basic ones work. Congratulations to you, and we'll see you in the next class time we get up on the whiteboard. Thanks so much for being along today. I hope you found it interesting as I do. Thumbs up are appreciated, and your comments are always welcome. Thanks for being in the shop.